Hey guys, we're in the NMR lab today at UOW, and today we're going to go through the NMR practical side, where we're going to show you the spectrometer, how it acquires data, how to set up an experiment with it, and how to then get the data for processing, which you guys are doing at home. Normally, I'd process the data in the exact same way you guys are, so you guys have already looked at that part of the practical. So today we're going to be looking at the 500 megahertz NMR, which contains a cryoprobe, which can do much cleaner spectra than the other two spectrometers we have here, which is a 400 and an older variant as well. To set up a sample in this particular machine, what we do is we take a sample, such as this one, with some solvent, so the sample is dissolved up, and we place it in this glass tube with a sample lid on top as well. What happens now is we place it in a spinner. The spinner is to stop the sample from shooting off in different directions and going through the wall of the NMR machine, and it'll help the sample spin straight. So all we're going to do today is we're going to place the sample in the spinner, and we're going to place the now sample in the gauge. What you'll notice on the gauge is there's two things. There's a nice little 10 millimeter area line there, which is where the sample needs to reside. You need 10 millimeters of sample to acquire a good spectra. Any less or any more, and the spectra starts to get lower in quality. The other thing is you need to make sure the sample isn't touching the bottom of the plastic you can see at the bottom where my pinky is. What's there is the bottom of the spectrometer, and obviously you wouldn't want your sample to go through the bottom of the spectrometer. As you can imagine, taking it apart to clean it is actually quite difficult. So what we're going to do now is we're going to take the sample in the spinner, and we're going to place it in the machine. So this machine is a really nice one now because it has an auto sampler. That means really there's no actual intervention by the user to acquire data at all. So what you've got here is you've got, I think it's 65 samples in total along the top here where you can place in. So that means the samples can be loaded up, all 65, and run. In the case of UOW, that means students come down whenever they have time or whenever they want to run a spectra. They place their sample in and they set up an experiment and they walk away. And that means you can run as many samples overnight as necessary. We can set it up for 3 days, walk away. It's just a better, more efficient use of time. So what we're going to do is we're going to hit add on the little panel here, which is a little touch screen. We click go to free, so that'll set it up to go to a free sample holder, which it's already at. Place the sample in the spectrometer carefully, and then it's going to go to the next sample holder for the next free one. What we can then do is we can remove the sample too, just by hitting the remove button and then remembering the position of the particular sample. So in this case here, it was 34. And then we can remove the sample when it comes to the front. To acquire data, we just go to the computer once the sample is inserted, and we remember that we had sample holder 34. We come to the screen here. And what we do is we click change user. So the user you're given will be set up on this particular computer. So first things first, I log into my user, and then I can load an experiment on sample 34. To do this, the sample holders are numbered all the way down the left side of the screen. You find the sample holder, you click add, and it will load up a little section here where you can see it's got a box that's colored in blue. This contains a few different details, namely the date, time, your username, things like that. It also contains information such as the solvent, which you select, the experiment, proton, carbon, cozy, whatever you would like. So for example, just as your workshop instructions with the indinome, you could run a proton spectra at the top here, carbon spectra at the bottom. Alternatively, you can run 2D spectra such as the cozy at the bottom of this page here as well. All these things can be acquired on here, as well as actually phosphorus and fluorine, which you can do because we have a heteronuclear probe. This allows you to record every piece of data you could possibly get for your compound and solve your compound at home like you guys are in Mestranova. All the data will be uploaded to a share drive where you can access it. So once you know what spectra you want to run and you've titled the spectra correctly, you just right click and you hit submit. This will submit the sample to the spectrometer, where it will just move the sample holders around the machine. It will automatically inject the sample for you. It will automatically run the sample by locking, shimming, and acquiring the data. And it will then automatically inject the sample as well and allow you to collect the data off the share drive. So there's really no way for you to get this wrong. If the sample ever gets stuck or anything like that, sometimes you do need to get it out, in which case the technicians at the university handle that for the users of the machine. So what we're going to do now is we're actually just going to take a look at the probe in the machine. So what happens here is the probe is in the center of the machine, in between the magnet. So you can see at the bottom, at the center, straight up through the middle of the spectrometer would be the sample probe, where the sample is spinning. So we've actually taken one out of a spectrometer here. This is a magic angle spinning probe. And what happens here is you actually have this inside the instrument, and it sits in the middle of the magnet where it's going to acquire the best data, and the sample will spin around. So in this case here, this particular sample here will go into the magic angle spinning probe, and it will sit inside that little yellow window here, just like that, spinning at the perfect angle to acquire the best spectra possible. We don't use this particular probe for all spectrometer runs because it is more difficult to acquire data, because it's harder to get a sample in there than the other ones. So what happens here is the sample will spin quite fast, much faster than the normal probe we just looked at, the normal samples. And in doing so, we'll acquire a much nicer spectra because it is spinning at the magic angle. So once data is acquired on the spectrometer, you can look at the bottom screen just here in the computer. And by double-clicking on a sample in the out window on the bottom, you can actually take a look at the spectra. So in this case, that was the proton in D2O we just looked at. And on the left here, you can see some peaks, which are the sample peaks. We've also got a cozy here as well. So this is a cozy spectra that's just been acquired. Same sort of thing. It allows you to run 2D spectra as well. Depending on what particular experiments you want to run will depend upon how long they take. But again, you can acquire proton, depth, carbon, cozies, all the other 2Ds, HMBC, HSQC, and also fluorine and phosphorus as well. Yeah, is that good? Sorry? Oh, you want an ending? So good luck interpreting your data. But the data interpretation you guys are going to do at home is pretty standard to what everyone does. Have a good go at it and actually try to learn how it works, because next year when you guys come in, if you do, to do honors or a PhD, it's exactly what you're going to be doing when you go to do experiments, and it's actually what you need to do for synthetic chemistry.